Colleagues, hello. Today I'll try to defend the AutoML. I think that we kind of forget what we needed for in SOCs because LLM agents are now conquering everything. Okay. A few words about myself. I spent some time in the integrator, in the vendor. I also built the magic kind of triangle of Russian cyber security. I primarily dealt with development of security solutions. There are two parts to my speech. So we'll talk about the practical kind of use of this. So how can we survive if we don't have vendors, if we kind of have to build this from scratch? Then we'll talk about your throughput increase, how to build the systems quickly, reduce the resources, and how to make the system autonomous. Okay, what's the value coming from detection model at the classical level? There are two anonymized cases for you. I was asked to anonymize them. So in the first one, so we have some. So this is a critical vector. We have attacks. So we have some automated systems. We have information security systems. So let's build the LM. Yeah, we have this, and we have reduced our white spot. Everyone is happy. And this is an opposite case. We have a detector kind of catching all the attacks, but it generates too many falses. So this analyst just work with a 24/7, and they're really unhappy. So we tried to begin with statistics, not rules, but statistics didn't help us either, and that's why ML helped us. We made it more precise, and we managed to find new attacks called anomaly detection. Okay, let's further decompose our task. So why we are going deeper here and using ML for detection? Well, we have expertise, we have ISS, so why we should use it? So they use it in the SOCs at the coordination stage for gathering context or to analyze cases. Okay, why? Well, we can get rid of false positives, we can make it more precise, we can do aggregation, we can develop aggregates, so we can look at these false positives through ML agents. But if we miss something at stage 2, and this is most likely to happen, then we'll have nothing to filter through. So to reduce our blind spots, to see the unknown threats, we should target the second stage. So this is our vision, this is our personal opinion. Okay, what are our options to sort this out? So we have rules and statistics, they work quickly, everybody understands how to do it. I have developed them myself throughout my career, but if we have some non-trivial case, then we have to invest too much time to support all this, to change the conditions, to change thresholds, populate the whitelist. So this is a nightmare. Here ML helps us, because if you build it properly, you don't need resources. We scarcely need any resources for ML models here, but they're a little bit slower and a little bit more difficult to interpret. But their interpretation is still higher than for LM detection. So LM detection is a new trendy field. We kind of narrowed down the data, and we look for things using the LM. Well, it works for some cases, but in the SOC, most of the data is structured, and Ira mentioned that too. Well, you should use it. So that's why ML is a big thing, but LLM detection is also promising. Okay, the components. So you know that we look for anomalies, and we have a classification.
наши модели в разрезе того,
So we look at our models. We understand that we need some binary yes/no attack on a given entity. So we look for anomalies using some indicators like the user, say the host, and then we look for different types of discrepancies. We have a lot of false positives. We don't know what to do about it. So we buy some solutions like EBA, then we throw them away, and so on.
в наших глазах не очень хорошее решение.
We don't consider it a good solution. How do we overcome this?
Все могут себе представить фонарик, который...
You can imagine your light torch, like highlighting some pieces of our infrastructure. Some light torches are different. You can change their aperture. And so looking for anomalies, we have this this light torch, and we can focus on what we are looking at, what we need to be looking at to reduce the false positives. So we kind of reach this understanding. We looked at some analysts and how they deal with alerts. So they don't usually think too much when they look at the alerts. They usually have some signals, and so they believe that, okay, this is suspicious, that is suspicious, and this is too suspicious. And all of this taken together is too suspicious. So this is most likely to be true positive. So this is how we look for anomalies. So we have classification, we have tags, so we accumulate them.
Если вы заказчик, у вас такая ситуация, я вам сразу говорю, будет редко. Что же делать с разметкой? Все равно, потому что разметка нам нужна, даже если у нас поиск аномалий, все равно нужно как-то это все валидировать. То есть примеры атак какие-то нам нужны.
So we need some examples of attacks and some kind of good behavior. Examples. We have analysts, and analysts have their kind of judgments. We store all this. We have some artifacts. And we have different solutions, and we have simulations, manual, automated data. We have pentest data, and we also have this weak learning. Well, people underestimate it. Why? Well, we have correlation rules with some thresholds. We have quite a lot of them, so we can remove thresholds from them and take the conditions. And this will become
сделать различного рода правила, по которым...
a set of rules for tagging our data set quite roughly, but we'll find quite a lot of data. So if we have a lot of data and the data is not well tagged, but still tagged, this will increase our quality, just like a little data set tagged manually by an expert. So we should use it. And we also use some flags here provided by the by the ISS. So we should use them. Active learning. Okay, we have some tagging, and we need to improve our models. Then those who deal with models, they might take some samples.
Выдает наименее уверенный результат.
If we see that the model is not confident, so we can manually tag this and do these iterations until you reach the level of quality you want. There are some other tagging methods. We don't think that we should pay attention to them, but sometimes they are helpful, but we don't use them.
Давайте поговорим о признаках, которыми...
Okay, let's talk about some indicators we can use to direct the model looking for anomalies properly. Well, we can use either the structure or the features. Let's start with the features. Say we have some table data. So here we build a vector which is reinforced when the behavior of the entity matches our expectations. If we have time rows, then we look at the confidence intervals, and then we use these predictions to mix all this stuff together and to generate the features or indicators, which will also kind of
во всем, что мы можем
mean that we have an attack or something. Then we can develop some metrics and timelines. The same works for graphs. There we have nodes. There we have
определенного рода поведение.
kind of edges, and this will also kind of show that there might be some important events going on when the behavior of the entity matches this set of features. And we can compare this. In the graphs, we have the structural assessment of anomalies, and we can mix it with the target features. Okay, the models, what do they look like?
Последовательность блоков,
Okay,
которые мы можем выставлять,
the models are a set of blocks
получить
we can build in a proper way to see the pattern we want to find. So if we need timelines,
что нам нужно.
okay, or rows, we calculate it there, then we bring it to the second level model, then we consider the target features, and then we find the anomalies. And the same works this way for the graph. You can mix it in any way you like, and you can add some other things here, not necessarily only the graphs and kind of
библиотеки, которые мы
trusted rows. So we
главное, что
can do it easily. Here are the libraries we have for this. And the important thing to consider is that you should properly select the entity. So this could be your credentials or host or subnet or whatever. So you should split your pipeline into train and prediction. So I think that you kind of understand how it should be done. At the
метрики в правом
optimization stage,
оптимизируем,
the
что введено
metrics to the right are optimized, and what we see in green is monitored online. So when the model doesn't work properly, when it should respond, nobody will be happy.
разобрались.
Okay, it's enough for the models. Let's talk about speeding up the process, how to democratize it, and how to make it autonomous to an extent. Here are our results.
Удалось снизить кратно
We reduced the time dramatically, the time spent by one engineer to develop a system like that.
к этой обвязке AutoMLOps.
Then we added to the AutoMLOps some AI assistants, and we further reduced the time.
Что нас на самом деле.
And this makes us happy.
Давайте разберемся, из чего это.
Let's talk about this magical AutoMLOps. So we have the pipeline for a project when you develop a system to detect based on ML. So we have some tasks, we gather data, we generate features, and we kind of prepare the ML and we deploy it. So we have three components: AI assistance, AutoML techniques, and MLOps practices. So we start with MLOps, you build it, and then it's AutoML.
Делать
It helps you develop
более быстро
models
с помощью
quicker
алгоритмов оптимизации.
using various algorithms for optimization. You can pick the right features and models and parameters. The same kind of techniques mean that you have templates for your pipelines, and you can use it further when you develop a similar project. All the kind of predictions you have here, they should be shown to the analyst. So you should show the features which impacted the model, so that for them it should be kind of just as any other alert. A cherry for the cake.
Весь этот процесс немножко более интеллектуальным, потому
We make this a little bit more intellectual, because we understand that LM is just a storage of fundamental data, and it is likely to know more than you do.
странно это не
And it would be kind of weird to avoid it, because we need to target and expert features in our situations, and experts not always come with them. But here we have the LLM. This is a great thing to use. Okay, let's start with them. LLMs. Just imagine you are there in the SOC, and they tell you, okay, we have a lot of correlation rules. They generate a lot of false positives. Okay, we are paying you well, so please generate SOC on LM. So what do? So they make an LM app. They feed all the code base to it. So in our case, it can be easily done because it's written on a well-known language. So we add some statistics, and then through RAG we add some analysis. What was the reason of the false positives? So the right decisions of the model. So we add all of this to the context. We understand the rules we should bring to the ML, and which ML templates should be generated, because the development of one AutoML template
нагрузку скопом, потому что мы сразу
will reduce the load, because several systems are ML powered now. So we have a list of detecting systems. We have the template. Okay, we understand where the documents should be. We send it to the libraries. So we have so we have the input, we have the output, we understand what the pipeline should look like, and this should be for you just the first draft. You should understand how it works, but this speeds up the overall process. Okay, and what shall we do if we don't have any attacks? What do? So we take a framework with some name, and so they launch it, they see whether the correlation rule works or not. So we try to find what we have in the kind of blind spots. So we don't necessarily see whether we have this alert or not. And for this, we have an agent. We give this agent the tool we use for a specific procedure, the tools which help him or it find the logic, detecting logic. And we launch it in our infrastructure in a safe way, and we make it interact with the environment to collect enough attack examples to further hone the model. So the model cannot generate any gibberish here, because we kind of feed it with physical tools, physically taking the steps we tried to kind of find and teach it upon. Okay, now we should kind of catch some attackers, and we need features, and these features should be generated by experts. We are not necessarily experts, so we have the LLM which will help us. So we describe the task and the reasons, we send the pipeline code.
Без этих всех волшебных обвязок беседуешь там иногда с аналитиками.
You sometimes talk to analysts, you talk about some cases, you talk about the time it takes, what you pay kind of attention to, what you don't pay attention to, and you add all of this to the context, and it works really nicely. And what can we get? So we have our features, we have the AutoML template. It works. We developed it using some system. So we have a task for a new detecting system, and we have some data examples. So it's not an issue for the ML to generate a YAML config, which would be several dozen lines long. Well, it will not give you the whole system, but you can use a template for agents. You can give it to them as a tool to build a model for classical learning to find some anomalies. So when you develop the model instead of doing it yourself, so we look at this as a foundation for our pipeline. Well, the pipeline without these new features. So we have the YAML, we have the template,
подставляем YAML,
So we add the YAML to the template, and we roll out our models for training and retraining and tuning the models. So we get the initial versions of the trains. Then they work in the forecasting mode. We send the alerts to the analysts. The analysts are happy. So they now have view of them. We kind of connect it with our tagging sources, and then the model for looking for anomalies. So the infrastructure part is retrained regularly, and the part kind of responsible for the detecting logic. So we either look at the new attacks or we look at some shifts. For instance, if some things are no longer considered attacks, or maybe we want to focus on some other things, and you should be careful dealing with a supervised system, because you shouldn't retrain the model without tests kind of blindly. And there are three important things here. So we are talking about adaptive learning. So we understand that Tinkoff changes overnight. Every day we have new infrastructure. Then we have built-in tagging in our working processes, so the flow of the ML kind of product. So these guys kind of develop. So it is all built in the working process. So the analysts don't even know that they are taking things. And the third thing is live learning. So models are like us; they learn lifelong. So they should obtain new knowledge throughout their life and adapt to new threats. So what does it look like in production? So here we are. We have some code, most likely with a Copilot. For this we use the CatDraw framework. Here you have some graphs, and you can process data frames, and you can add to one pipeline all the chain of data processing, all the way from getting it from a source and all the way to the forecasts and sending alerts to the analysts. We have some modules for features calculation, so we can commit there, and other experts can do it. LLM agents can also work there. We have an infrastructure for dealing with LLMs. Otherwise, you will not generate this workflow. So agents, if things are slow, we do it in Airflow. In workflow, the quick things are done through time. It all predicts something. We send things to the Kafka, then it goes to the Hive, and everybody is happy. The data we will take from it, so it can be storage or a stream of data. The artifacts go to a stream and fast grew. So we monitor this. So we know all this. Well, I go to Elastic, for instance. So Elastic is with me, and the only thing that a SOC wouldn't have. So maybe you'll need to add some experiment tracking system, because this is really useful. Okay, some conclusions. Okay, ML is useful. It improves our metrics for identification. It doesn't necessarily need sophisticated models or tagged data, so this is a myth. But we should properly pick the right approach so that you can tell your analysts why the model makes decisions. A weak model could be strong if it is supported by your expertise. So, if the rules are right and if the statistics work, it's fine. But if LLM works, you should use LLM. So pick the tool properly. Well, AutoML will reinforce everything. And well, you don't need a perfect system, only showing you true positive without making any mistakes and so on. Well, this is possible only when vendors work, because they have everything tagged. But in the customer's environment, if you look at your metrics of detection through some window, you'll see that point 8 of the weighted metrics would be okay in terms of completeness and precision. So AutoML can be an autonomous system. You don't have to invest time into supporting this. So we have a system I committed half a year ago, or maybe even 3 quarters ago. So if you set it properly, you just run it and forget about it. Okay, this makes LLM systems more simplified for non-LLM experts. Well, you can fill in the YAML easily. So we reinforce the LLMs, and we believe that SOCs should be mature for this. Well, dealing with this stuff, you should teach your own stuff. I don't think you will be able to hire anyone from the market. Please do hire an MLOps, because MLOps will be more useful than 5 LLM guys. And if you guys want to be ML experts, well, this is good, because they'll be more useful for you than a third-party expert. So you should add first models to the response time, then add to them the MLOps, and then you should add templates. Thank you.
Да, Дим, спасибо.
Okay, thank you, Dima. Do we have any questions?
Да, есть.
Добрый день.
Hello, my name is Alexander. Thank you very much for your speech. It's been really informative and exciting. I have a question. So, do you believe your LMs, or do you have any expert validation? Well, here's the way we have established it. If we build a new system for detection, we send it to production, and we look at this metrics. You remember, we compare it to the standard methods, so they run in parallel for some time, and then if we are confident that we don't use these classical methods anymore, we just phase them out. So do you mean whether we interpret the results? Yes, we do. Well, I mean the post-analysis of the decision of the LLM, either detect or non-detect. Okay, the analysts tag all this. So we look at this tagging and we validate the metrics all the time. Okay. Coming from this slide with the metrics, you say that you don't need much resources to support ML. And so is this something completely autonomous, or do you need to fine-tune it, to hone it, to double-test it, or to test it periodically? So we generate the traffic, we understand that this is anomaly, and so we look at the decision of the ML model, right? I'm a little bit lost in terms of your question. Okay, I mean, is it completely autonomous? Okay, if the framework is autonomous, if you kind of predict the issues you might have and how you need to respond, how quickly you need to teach your model, how to change the detecting logic, you can do it in an autonomous way. If this is not enough, you can add some statistical tests. If you don't have alerts for some time, but you should be confident that the system is still in a good shape, then you should come up with some options for stress testing for your system. Your security in-house engineer can help you with it. Thank you. Any other questions, please?
Да, Дим, у меня вопрос тогда.
I have a question.
Ты сказал, что
You mentioned that it's difficult to find a third-party ML expert, but you can teach your in-house guy to become an expert like that. But what kind of qualifications should this guy have? So who would be your good kind of candidates for this? Yes, I'll try. I'll try to mention this. Well, the situation in terms of hiring. So you have this classical triangle of data science, the domain field. In this case, it's the SOC, because cybersecurity comes in different shapes, and so on and so forth. So it splits in subdomains, like the algorithms and development. If your detection engineers use some language, be it for the rules, for the SIEM or Python. So they're likely to survive some development of ML models, but they can give it the expertise. The third-party ML guys will have to spend, say, 10 years to have this expertise, to understand these indicators which would be suggestive of a threat agent's activity. So I believe you should kind of look at these guys. So you can develop your own guys. But if you hire a third-party expert, well, I had a similar situation. I deal with other ML guys, and I ask them, do you want to join the SOC? They say, well, you have some strange and weird tasks. Frankly speaking, I don't want to go there. Well, I say, well, if it's weird, you have some growth opportunity. But they say, well, I don't know. Well, if this is a professional guy, he or she should show that they're making money for the kind of business guys. So that's why they don't want to go to the SOC. So you should develop your own guys so that so they shouldn't be afraid of hackers. Yeah, those who are about catching hackers, not about making money.